what I've decided to do is, well, we're going to go through as much of this as we can. I don't see us getting through the whole thing, but I want to try to get through most of it. Because we'll do this today. Tomorrow, I'm going to have to find those. Oh, here they are. Yeah. So we're going to go through as much as this as we can. Mainly because since we've been gone on and off for so much of this year, I wanted to go back over this today. We will go over the review sheet tomorrow and then test. So it's just getting more practice with factoring, looking at factors, and solving these here. That way also, if you do have questions, we can definitely go over those. Okay. Give that back for now. That way you can at least have something to reference back to. All right. So when we look at any of these here, factoring, a lot of times, because again, I have a habit of doing this, but one of the first things we should be looking for in each set, each time we factor, is a greatest common factor. Most likely there is not one, but if there is, we need to factor it out. It will make things simpler, a little bit easier to work with. It doesn't mean that factoring out the greatest common factor will prevent us from actually being able to factor it. It just makes some of the numbers smaller and easier to work with. So if we look at number 1, because we can do 1 or 2, because they are similar in nature. If we look at number 1, greatest common factor, we're looking at 6, 13, and 15. We're not looking at the variables because x squared x, no x term. There's not one. It has to be in common in all 3. 6, 13, 15 does not have a greatest common factor. Primarily, well, one reason is 13's prime. So there's not going to be anything in common with these 3 here. So that does take us to our second step, our 2 sets of parentheses with 3 spaces. Then we look for the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite, immediately opposite. Here, the third term is negative, so our signs are opposite. One's going to be positive, one's negative. I just habitually put plus first, minus second. It really doesn't matter. Third step is to find the factors of the first and third term. Well, 6x squared, x squared will have x and x. Now 6, we have 1 and 6 and 2 and 3. 1 and 6. 15. 1 and 15. 2 doesn't work. 3 and 5. 3 and 5. And the last thing we can do is check. X times negative 5 is negative 5x. 3 times 6x is plus 18x. And 5x plus 18x is indeed positive 13x. It is the middle term we wanted. If it's not the middle term we wanted, we can start off by switching the 5 and 3 and trying it again. And if that doesn't work, then we can try a different factor of 15. If those don't work in either set, then we switch the factors of 6. If we do get the correct number but wrong sign, change the sign. Change the sign, and that should get you what you need. So that's it there. Questions on number 1? I'm going to skip number 2 for now because that's very similar to number 1. I think we feel good with some of these here. If there is one that I skip and y'all want to see it work, ask, and we'll go back to it. Because I do want to look at number 3. Number 3, we do have two terms. X, we have 9x squared minus 16. The x squared kind of gives us a hint at what we're looking at, because it's a perfect square and we're being subtracting these two here. So we need to see if these are two perfect squares. 9x squared, what times itself is 9x squared? 3x and 3x, because 9 is a perfect square, it's 3 times 3. X squared is x times x. Is 16 a perfect square? Yes, that is 4 and 4. So this is our difference of perfect squares. Because if we have two terms and they're being subtracted, we could have a difference of perfect squares or we could have a difference of perfect cubes. One of the main telling signs between difference of perfect squares and difference of perfect cubes is, well, if it's a difference of perfect cubes, the variable should have an exponent of 3. Difference of perfect squares, the exponent with the variable should be 2. So that's one of the giveaways there. Now, even with these here, we would, or still should, look for a greatest common factor. Well, 9 and 16 does not have one. And even if it does have two terms, we could have variables that are common factors. Here we do not. So this is indeed a difference of perfect squares. We still have our two sets of parentheses with 3 spaces. Difference of perfect squares, our signs are opposite. One's going to be positive, one's negative. And we fill in our perfect square terms. As we said, 9x squared, that's 3x times 3x, or 3x squared. So in the first spots, we would have 3x and 3x. Our perfect square term for 16 is 4 and 4. So it'd be 3x plus 4 and 3x minus 4. Now we do write the 3x squared minus 4 squared as a way to know what numbers or terms we put in each spot. Oh. So at this point here, we're just factoring. We can check it, yes. Because if we check this here, 3x times negative 4 is negative 12x. 4 times 3x is plus 12x, giving us 0. Because we don't have a middle term, so it should be 0. And on some of these, if we know we're used to solving these, we know we got the correct set of factors, we don't necessarily need to check. The main reason we do check is to verify that we did get it. Does that make sense? Because on some of them, especially like the first one here, there's multiple ways we can set this up. And with difference of perfect squares, 3x, 4, we set it up, we can move on. Because one of the ones I wouldn't necessarily make sure to check is sum and difference of perfect cubes, because we pretty much have to multiply that whole thing out, and that is a lot of steps to do. Questions on number 3? Do we want to look at number 4? Let's look at number 6. This 5 seems tricky, but it's just figuring out the factors for it. 6, again, all the ones that we've had up to now, 5 doesn't have greatest common factor, but 6 does. What's the greatest common factor for 6? 2. And if we factor a 2, out of all 3 terms, we get 2 times 7x squared minus 9x minus 10. Now, since we're factoring and not solving, we do need that 2 all the way to the end. It's going to be included in our answer. If we're solving, we don't necessarily need it. It's just a scalar. Now, at this point here, we can look back at 7x squared minus 9x minus 10 and see if there is another greatest common factor. and there's not one here. Because sometimes it might be hard to see what the greatest common factor is, but if there's one that we do see, factor it out, and then see what's left, and if there's another one, factor it out again. Because if we factor out more than one, we take those and multiply them together to get what the true greatest common factor is. But since there's not one, so if we factored out another one, let's say another factor of 2, we would multiply those greatest common factors together, which if there was a second 2, it would mean that the greatest common factor is, well, 4, 2 times 2. If it was 3, we would do 3 times 2, which would give us 6. That way, you're not just sitting there trying to go through every possible set of factors. We can do one, see if there's another, pull it out also. Next step is our signs. So they would be opposite since the third term is negative. If the third term is positive, signs are the same and match the sign of the middle term. So 7x squared, we would have x and x, and the only factors of 7 are 1 and 7. So I'm going to put the 7 in one of the places. Factors of 10, 1 and 10, 2 and 5. 2 and 5. So I'm putting it this way here mainly because, well, we know we're going to have to multiply the 7x and this number over here. I didn't put the 5 there first because, well, 7x times 5 would be 35. That's a little big. We'll try it in a minute if this one doesn't work. 7x times negative 2 is negative 14x. 5 times x is plus 5x, giving us negative 9x. Is that the middle term we wanted? So that's it. Now, if we were solving, then we would set both of those equal to 0 and go from there. But since we're just factoring, that's as far as we need to go. Does that make sense? Does that answer your question? Or? Yep. You're good. Yes. Questions on this here? Let's look at number 2. 8x cubed plus 27. 8x cubed plus 27. Our x cubed is telling us this is most likely going to be a sum or difference of perfect cubes. The only other way that we would have an x to the third term is factoring by grouping. But factoring by grouping, we need 4 terms. We need to group them in pairs of 2s and go from there. So what we can do first to help us solve this here, yes. So when we do find these, we'll have set of parentheses with 3, set of parentheses with 5. Yes. And, well, it's more the cubic. Because our first set of parentheses is what we call linear. The x power in that is going to be 1. So linear equation, equation of a line, is just x plus a number or number times x. X is to the first power. The second set of parentheses is going to be a quadratic, degree 2. So we have our degree 2 times our degree 1, which gives us the degree 3. Does that make sense? Now at this point here, we can plug these into the calculator. The cubed root of 8x cubed, well, cubed root of 8 is 2. Cubed root of x to the third is x. Now we can plug the cubed root of 8 in the calculator. It will do that just fine. We can't plug the cubed root of x to the third because, again, both calculators need a value for x. Cubed root of 27 is 3. So what that tells us is that there is a sum of 2 cubes. If we do get a decimal for these here, and especially on the test, it's not that it's not factorable, because I wouldn't do that on the test, it means there's a greatest common factor. There's a number that goes into both terms. So here, our first term is 2x. Our other term is 3. Signs, same, opposite always end on a positive note. So since we're talking about a sum, plus, same would be plus. Opposite would be minus. Always end on a positive note would be plus. So then we fill in our first term, which is our 2x, so we'd have 2x. Our second term would be our 3. So the first set of parentheses would be 2x plus 3. In the bigger parentheses, we'd have the first term squared to the first power, and then it's not there. It's really to the 0, but we just don't list it. Our 3, we don't put it in the first spot, to the first power in the middle, and then second. Now we do need to do some simplifying here. Really, the first set of parentheses is fine as it is. Now we do need to square our 2x. 2x times 2x is 4x squared. Minus 2x times 3 is 6x, and 3 squared is 9. Questions on this here? Now, especially on the ACT, not so much this factoring test. And the reason I say for the ACT is ACT, unlike this factoring test and most of my tests, actually have multiple choice. If the ACT asks you to factor a perfect x cubed plus 27, we know it's plus, so the signs have to be plus, minus, plus, yes? Any answer choice that does not have it set up that way is wrong, and you can mark them out. We know that the cubed root of 8x cubed is 2x, cubed root of 27 is 3, so we know the first one has to be 2x plus 3, yes? Any that don't have that, wrong, you can mark them off. And there's a good chance you'll either get down to 2 or 3 or 1 and you're done, and we didn't have to do the rest of the problem. Questions on 1 or 2? So 3, 25x squared minus 64. Difference of perfect squares is the only one we have. We don't have a sum of perfect squares, but we can have a difference. So our signs, plus and minus. What times itself is 25x squared? So 5x and 5x. It goes first because 25x squared came first. What times itself is 64? 8, so we have 8. Well, not so much divide by 2, but we can take the square root of the number. So square root of 64 is 8, square root of 25 is 5. It sometimes feels like we can divide by 2, especially with 4, because square root of 4 is 2. 4 divided by 2 is 2. That's just a coincidence. But we have this here, and that's really all we need to put. The reason we did the squared, the parentheses squared minus each other, was just so that we could see 5x and 5x, 8 and 8. It's not a necessary step, but if it does help, write it out. We can look at number 4, or number 5, sorry, number 5, our 4x squared. Because as it stands right now, we can factor it. This is factorable in its current form. But I would not suggest doing it, because I would factor out the greatest common factor of 4 first, because the number of factors of 360 is quite numerous. Because if we factor the 4 out, bless you, we're left with x squared plus 1x plus, and the third term has gone from 360 to 90. 90 is still a significantly big number, but not as much as 360. Two sets of parentheses. Since our third term is positive, our signs are the same and match the sign of the middle term, x and x. Factors of x squared are x and x. Factors of 90. 1 and 90. 2 and 45. 3 and 30. 4 is not a factor of 90. 5 and 1, 18. 6 and 15. 7 doesn't work, 8 doesn't work, 9 and 10. And I would suggest especially increasing it by 1. Start with 1 in the number, then try 2, 3, 4, 5, 6, going up. That way to make sure that we get them all. We stop at 9 and 10 because the two sides have met. 9 and 10. So and this is not so much a rule, a set rule for how to do it. If the middle term is smaller or closer to our factors, I go kind of smaller. If the middle term is big, one direction or the other, I try bigger factors first. And it's not that it will always work that way. Something I've seen that works, and it helps me eliminate some of them because 19 is not a small number, but not a big number. So most likely 1 and 90, 2 and 45, 3 and 30, the likelihood that those are going to be the correct factors is very low. So I avoid using those first. I see that it's smaller, so 5 and 18, 6 and 15, and 9 and 10. I would try there first. And if we did check this, x times 10 is 10x. 9 times x, bless you, is 9x, which does give us 19x. So those are the factors. Questions on this here? Yep. In that case, I'm going to look at 3 from day 3, and then we'll move to day 4. This one here, 9x cubed minus 27x squared. I will tell you there is one like this on the test, similar to this here. Greatest common factor between these two here is 9x squared, because 9 and 27 do have a greatest common factor of 9. X cubed and x squared have a greatest common factor of x squared. And we could factor this out. And if we factor 9x squared out of 9x cubed, we have x minus 3. And that's it. Now, inside the parentheses, if we want to make sure that it is simplified, one of the giveaways is that the degree of it is 1. So inside the parentheses, x is to the first power, so the degree is 1. We're done. There's no other way to simplify this further. Because the 9x squared is a single term, there's no way to simplify it further from there.
All juniors need to check their Google Classroom for prom information. All juniors, check your Google Classroom for prom information. Thank you.
Yeah. Yeah. Yeah, yes. All right, guys. Let's look at number 2, because this will actually kind of flesh out something we mentioned earlier. Because if we look at 16x cubed plus 128y cubed, is there a greatest common factor between 16 and 128? 2. So if we factor 2 out, we have 8x cubed plus 64y cubed. Now it does work out, 8 and 64 are both perfect cubes. But is there still a greatest common factor between 8 and 64? And it is 8. Okay. So even though we factored a 2 out first, we can still factor out an 8, which would give us x cubed plus 8y cubed. The 2 and 8. So what that tells us is the actual greatest common factor of the original was 16. That we could have taken 16 out of both. But instead of trying to go through all the different possible factors and working through it, we saw 2 work, so we took it out first. Then when we looked at our result, 8x cubed plus 64y cubed, okay, we can see 8. Between those two, we could factor it out. Or, if we didn't see 8, well, I can see 8 and 64 are both divisible by 2, so I could factor it out, which would have given us 4x cubed plus 32y cubed. Oh, 2, 2, 2. Yes. Now our signs are going to be the same, opposite, always end on a positive note. Now I didn't write it out. I'll go on and do that. Cubed root of x to the third is x. Cubed root of 8y cubed is 2y. Our first term, our x, in the first spot we would have x squared, x, no x term. The cube root, yes and no. It's almost the same as when we did the sum or the difference of perfect squares where we wrote them in parentheses squared. It's not a necessary step. I'm not going to count off if you don't do it. It's just a way that I know when I'm filling it in. Yes, that way, yes. When we're filling in our x in parentheses squared and our x to the first, we know kind of what's going in those spots. It's a way for us to plug those spots in. Yes, but first we do need to finish this here because it would be 16 times x plus 2y. Our x squared is going to be x squared. Our 2y times x is 2xy, and our 2y squared is 4y squared. It does not. The reason we do that is according to number theory, that we put in alphabetical order and then descending power. Questions on 3 and 4? Number 4. So we do have 4 terms cubed. So we're going to do factoring by grouping. Now we're looking at 12x cubed minus 15x squared and 25 or 28x minus 35. Now, normally we do the first two, our cube and square term, but we don't have to. Because if you look at these two sets of terms, pick whichever one you can find the greatest common factor of easiest between the two. Because if you're struggling with 12x cubed and 15x squared, well, 28x and 35 have a greatest common factor of 7, yes? And if we factor, let's finish this up and then we'll talk about that. One more problem. If we factor out the 7 from 28, we have 4, and we still have an x. Minus, if I take 7 out of 35, we have 5. And we're factoring out a positive 7. Now we know we don't need to factor out a negative 7, because if we look at the first term with 28x and 35, we have positive, negative. If we look at the cubed and squared, cubed is positive, squared is negative. So the signs are already matching. So we have this here. Now it seems a little odd that we would do it this way and not do the first two terms first. But with grouping, factoring by grouping, we need to have something in common with both of these once we factor out that greatest common factor, yes? So what's inside the parentheses in the first has to match the second, yes? Which means if this is going to work, this is also going to need to be 4x minus 5, yes? 12 divided by 4 is what? 3, yes? 15 divided by 5 is 3, yes? So we know we'll need 3, and this is part of the reason I say find whichever one of those two sets you can find the greatest common factor easier, because those two sets of parentheses are going to have to match. It kind of gives you a roadmap of what the other one's going to have to be. Now at this point here, we can factor the 4x minus 5 out of both, giving us this here, 4x minus 5 times 3x squared plus 7. Now, if you saw the greatest common factor out of 12x cubed minus 15x squared, you can do that one first. Either or.